Well, now that we have our tuner application going on, and of course this is the free Gizmart guitar tuner. That's G-I-S-M-A-R-T. Looking pretty good. If it gets confused or can't track any of the higher frequencies, because this is a guitar tuner after all, I'm just going to switch over to this one, which is the Binarts, B-I-N-A-R-T-S. I guess that's sort of short for binary arts. And this guy here, I think, is a better, more accurate frequency meter, but it's a paid piece of software. So again, just know this is probably a more pro solution, but I'm going to use the guitar tuner for the most part, just so that we can do it with the free application. And again, it's connected via this cable to my calibrator box, which of course I've already shown you, and I'm going to be selecting voices from this control panel here. So we're all set up and ready to go. So now it's time for me to show you the magic of the super calibration. Calibration of the filter frequency and the filter frequency width is handled by the following trimmers. Let me just zoom in here so that we can give you a better view of the trimmers in question. Alright, so here I am looking at voice number 1, and I'll show you. The one directly underneath the filter chip, so here's the filter chip, and then I straight line down, there is this guy here, and then this one over off to the angle, up higher, right like this. Okay, so it's this guy and this guy. VR29 and VR28 are going to be handling the frequency and the width of voice number 1 respectively. And then that little pattern replicates in sort of a mirror image on the other side. There's VR24 and VR94 over here. And that's how it works. So this is how we're going to be doing it. I'm just going to be doing that off camera because I wanted to show you what's going on here with the frequencies in question. So let's go on up again, just so we can display all of this. Yes, and you get to see the crazy background of the rest of my workshop. That's quite alright. It's messy down here, but it works for me. Alright, so let's start with voice number 1, and I'm basically going to press the absolutely bottom, and again, here's the way it works. I press the absolutely lowest C on the key bed. Oh, I'm going to have to go and move this 0 production values to get my lowest note, and I'm going to tune the frequency to that. Then I'm going to go all the way up, all the way up, all the way up to this highest C here, actually this highest C, and I am going to tune the width so that I get the frequency I want for that. Alright, does that make sense? Okay, let me back out a little bit and see if I can explain this numerically. What we want is this. This guy, 65 to 66 hertz. This guy, 130 to 131 hertz. This guy, 261 to 262 hertz. This guy, and each guy is a C by the way, 523 to 524 hertz. And this one, 1046 to 1047 hertz. And then this one, 2093 to 2094 hertz. I know that sounds crazy, and the way we're going to achieve it is this. First thing we're going to do is we're going to peg the frequency. Then we're going to go up to the highest note, hit that, and adjust the width until it gives us the exact value we want, 2093 to 2094. Then we're going to go back and check the frequency again and discover that it's actually shifted, because the two of them interrelate. And we're going to bounce backwards and forwards between the two of them, ever so weaving in closer until we actually get what we want, namely 65, 66 hertz on the very lowest note, and 2093 to 2094 hertz on the very highest note. And when we have that, thereabouts, as close as we can get it, we test the individual C's in between, and they should fall within that range. So I'm going to do this for voice number 1 to show you how it's done, and I think we should be good to go for the rest of them. I'll just cut to the chase, and I'll talk to you again when we're all finished. But let's begin here. So I'm holding down this very first note, And thus begins the long and tedious process known as super calibration, 12 tone. So it says the frequency is 745, and is that right? No, that can't be right. This frequency is actually 167 hertz. So this guy is not getting it. Let's see here. He's not responding. Let's go over here. Let's come back over here. That might wake him up. Okay, I think that was a little bug. If you do a context shift to another application and back again, it doesn't always come back to life. You have to do that little shift there. That would be a bug report for the manufacturer. But again, Gizmart, unbelievable deal. Free? I mean, get real. Okay, so 168.5, and it says 168 down here on the scope. We are good. So I'm going to now adjust this. Oh, and I'm making a huge mistake. I can't do this until I have the correct test program running. Otherwise, all the calibration will mean absolutely nothing. On the V2 firmware, this will the test program that you load, test program number 3, will be the correct one. But right now, I'm using version 1.03 to do this calibration. So I'm going to need to load that with the editor. I'll be right back. So this is Vizex Kiwi-106 running with the test patch number 3. This is test program number 3, except that this version doesn't have the exact right value here for the low pass cutoff frequency. So let me just adjust this. I'm just going to duck into the camera shot here and double click and say 1450. So I've just entered 1450 in the dialog box. And I'll say OK. And now it says 1450 is the cutoff frequency. That's really important. The cutoff frequency of 1450 is the keystone. Now, as I said, in version 2 of the this program is going to be built right in when you go into the programming calibration mode and you choose bank number 3. So no need to worry about you having to do this when you're using V2 firmware. But I needed to do this because I'm not using V2 firmware yet, at least not on BT synth. So resonance is up to full, keyboard is up to full, but the VCF has to be at 1450 because that's the magic value that we are tuning against. And that means that when you want 12-tone tuning in your patches, that is the value you enter in the editor for the cutoff frequency, and you don't mess with that. And if as long as you do that, you will have tuned filters. Sound good? Okay. Let's move along back to the tuning then. Now that we actually have the reference loaded up, we're actually ready to go. So zoom out so that we are looking at everything in question. And now I'm going to press the lowest C. Okay. And there it is. I'm going to have to basically, because this isn't in test mode and they're not all locked in unison like that, I'm just going to be doing this. Actually, I could put it into unison voice mode, but let's not. Let's just leave it where it is right now. Okay, so frequency says it's 55.6. This frequency didn't update properly. It might have fallen asleep. Let's wake it up. Come on now. Too low for you, I think. 109.5. Yeah, it's not getting anything. Because it's 55. That's a pretty low. That's pretty low. Okay, so I'm now going down to VR 20. And I am adjusting it, and you'll see that the frequency is now going to change. And according to, oh, I'm going to bring it up. I want 65. Let's see if, when I take it up to 65, down here, does this update? It seems to think it's 109. So again, low frequencies. This is one of the reasons why this cable that I made is actually not the first one. The first one I made actually was sending a audio signal out to some speakers, and then I was listening to them just with the built-in microphone, and I discovered all the low-end stuff gets lost in these little speakers, so that just wasn't on. So this is not catching it. Let's see what's going on here. Look, the frequency meter gets it, so the Binarts one can't be fooled. It's reading 64.59, and this guy's reading 65.3. So I guess there's a slight discrepancy between the two of them. But anyway, that's what I wanted. And so now I'm going to hit the highest note. Alright. And it's 2196, which is pretty close. What I want is 2094. So I'm going to just deke down here underneath the radar if I can. Not really. You got to see the top of my head. And I'm adjusting the width. And I want it down to 2094. And that's as low as it's going to go, 2110. But now you'll see that because I did that, when I go back to the actual frequency, it's now telling me it's bouncing between two frequencies. The scope, on the other hand, it doesn't have any discrepancies. So again, we're sort of seeing some confusions going on here. 75.17. So we're back to the base. So I want it down to 65. 66. Okay, that's 66.6. And here it says 64, but oh well, what are we going to do? And 1851. Okay. Okay, turn on it to 2093. You know, the precision here is not what I'm accustomed to from having using a frequency counter. Well, let's keep tuning. Okay. 65, 66, at least down here. Back to the low one. Now it says 69 here and 64 here. I'm starting to question the sanity of all of this. Let's see. He needs to get woken up. All right. Um, 69.4, 69.7, they are in agreement. Okay. Let's continue using this guy and see if we can get any love. Why did it just go dead? It just lost it. Okay, a higher note's fine. No. We're just having lock-on problems at this low frequency that just aren't happening. And then back here. Alright. Not really sure. Okay, it's time to go back to this scope here and see what he has to say. He says 65 hertz. This is 67 hertz. So I'm getting discrepancies again. Okay. I'm going to be right back. I'm going to go and plug in my frequency counter and we'll test off of that as well. Alright, so let me show you a properly calibrated voice. If we take a look over here, it says 65 hertz down here, and its display down here is 65.6 to 8 hertz, and that's the lowest note. So I'm going to press the highest note. There it is. And the function generator says 2090, 2089, 2090. And the frequency response here says 20.08 kilohertz. That's the problem with the display there. It's not as nice as in the frequency counter, but it's very accurate. So now I'm going to test the first octave, and that should be 130 to 131. And it's coming up as 130 here, and it's coming up as 130 here. So now the next octave, and that should come up as 261 to 262. It's coming up as 260, but it's coming up as 261 and 262. Yeah, on the frequency counter, and then it's kind of jumping between 260 and 263 on the scope. So that's well within tolerance. Next octave should be 523, and here it is 520 and 523 here. So again, the frequency counter really is the most accurate of the tools I have, and I haven't been able to replicate that kind of accuracy using an iOS with a microphone input, unfortunately, and I've tried, as seen earlier on in this video playlist. Next one should be 1046 to 1047. And it says 10.04, but then it's here it's 1040. That's really close. And of course the very highest octave is coming up as 2088, 89, 2092. Yeah, okay. So this guy, voice number 1, is completely tuned. So now it's time to move on to the next ones, and I'm just going to repeat the process all the way along, and that will get me my super tuning 12 tone across the keyboard. So here is the final calibrated synth, and if I play a note, filter, bring up the sub, you'll see that's in pitch. I'll bring the oscillator an octave down. So as you can see, our filters are now completely in tune with our oscillators. All right. Alright, now that we've got the filter tuning all sorted out, it's time to basically load up test program number 6, and that would be here in test mode, bank 6, which is a noise program. And it's going to just generate a whole lot of noise. As you can see, right there on both scopes. And I have this scope here set to 2 volts vertical. So this is 2 volts per division, so it's 4 volts peak to peak. And if I hit this, that looks pretty much within the 4 volts peak to peak mandated by the manual, so good enough. Move along. Had it been necessary to actually adjust the white noise level, that would have been VR32, by the way. So let's move on. Okay, so now it's time to do the PWM on BT synths, which of course we're going to calibrate the pulse width modulation as controlled by the PWM slider. So that's test program number 5. So that's been loaded, bank number 5, press that one. And now that we are inside the voice board, the actual trimmer is VR31, which is right here. Okay, we're right there, right where I'm pointing, right there. It's got a green capacitor here and another green capacitor over here, and then a orange capacitor right next to it. So that's the guy, and really all we're doing, let's take a look here, is when we play a note, we're going to see what the duty cycle is. And the duty cycle is the percentage of the width that's up to down, basically. Okay. So I'm seeing a duty cycle of 51.3%. Let me just adjust this on the, pardon me while I get in the way. Okay, let's adjust the time base a little bit. Okay, there we go. That's adjusted the time base now, so you got a better idea of this, and it's 51%. So I'm going to adjust that and watch what happens when I adjust VR31. You see how we go basically to varying levels of harmonics come in as we sort of go out of that total square ratio. So at 50% duty cycle, we're going to see a true square wave. And I'm calibrating it down to exactly 50%, as near as I can make it. It's now going 49.9%, 50%, 50%, 50%, 49.9%. So that is calibrated. Now, the next thing to try, having done that, is to grab the front panel slider. I gotta stop playing here just to position this. Okay. Okay. That was the note I was playing before. Okay, and I'm going to push the PWM slider up. So here it is at 0. We just calibrated what it is at 0, which of course is a proper square wave. And now take it all the way up to full. And that's a 96.5% duty cycle. You see, because it's basically only like 3.5% of the cycle is on the up. The rest of it is on the down. And that's good. It should be within 90%, like basically from 90 to 100. So that's good. So this is all good. Okay, really at this point we're just going to move on, and we are going to check just to make sure the chorus circuit is biasing properly, and we're finished. Okay, so to do this one you need a function generator or a source of a 1 kilohertz sine wave at 10 volts peak to peak. So it's pretty specific. That's why I have a function generator here. The one on the left hand side is the function generator. The one on the right is the scope. They're both USB devices. They're both plugged into the laptop, and I have the output from one connected to the input to the other, so that you can see here on the screen we have got a 10 volts peak to peak 1 kilohertz sine wave. And what we're going to do, the way that this works, is we're going to load up any program will do, but this is the brass patch 1.1 that comes in the factory bank, and that one already has the chorus turned on, which is good. And we're just going to normalize the VCA level to 0 just to ensure that there's no amplification stuff going on. And then we open the lid. Okay, analog ground for both the generator and the scope probe go here. And now the actual signal for the signal that we're generating goes into test point 2, which is just to the left side of this white plug. You can't see it, but I'm going to plug it in here. Oh yeah, coming out the headphones. Let's unplug those. Okay, I've unplugged the headphones because I didn't, the headphones were unhappy about that. And then this, of course, is the test probe here, which we're going to actually seek out the test points. Okay, so 2 grounds going into the ground. The test signal is going into test point 2, just over there. And then I have the probe here, and look where these test points are. They're here on the board. This is test point number 1, right at the foot of this capacitor here. So we're going to touch this, and when we do, boom. No, not boom. You'll see. Alright. You see that? That's nice and balanced. Look at it over on the analog scope. Okay, that is a nice balanced signal. So the sine wave is essentially being clipped, but it's being clipped equally. As you can see, it's being equally clipped there. So that's a balanced, nice balanced. Okay, so that's one of the channels. And now we go to test point number 2, which is just down here, right on this side of this resistor here. That's test point number 2. And look, also nice and balanced. So no need to adjust anything with any trimmers. If you did, the trimmer is right there. Okay, so that's done. All right.